Hello and welcome to Stress-Free Longevity. This is episode 23 and today we're talking about microplastics with Professor Richard Thompson, who coined the term and has been one of the leaders in the field for the past 30 years. Lots to discuss. Let's jump right in. So, Professor Richard Thompson, welcome to Stress-Free Longevity. We usually like to start with just a little bit of basic science. Is that okay? So we're about to talk about plastics and in particular microplastics. But just a quick reminder about plastics themselves. What are they? How are they produced? And what is it about them that makes them so useful?
Plastics are polymers made essentially from fossil oil and gas, some now made from renewable sources such as plants and microorganisms. But the carbon can be polymerized into a range of what is essentially highly durable polymers such as PVC, polystyrene, polyethylene, the things that we're all very familiar with. And we can then, from those polymers, we can make products at very low cost. And I often think that if I go back to the history of the creation of those polymers, that dates from about 1830 to about 1910, these were fundamental breakthroughs in science, the fact that we could now make these complex polymers. Where did that change? Initially, they were used to make highly durable items, things like door handles and light switches, things that actually were seen as, to some extent, beautiful products, but products that actually commanded a higher price than the conventional materials that we'd been using beforehand. Then in the 1950s, what we saw was, again, innovation and advances, but for the mass production of plastics. So from the 1950s onwards, for the first time, I think, in all of humanity, we were able to make things with the intent that they would not need to be durable. And this was the birth, if you like, of the single-use throwaway culture that we see today, that we could take these materials, we could make them into something with the view that it would only be used once rather than to make durable products as we had done so far. And that really shifted the investment, and it shifted also the culture. You know, I often hear that it's the consumer that's responsible for all of the plastic waste that we generate. But to some extent, we've had now 70 years of behavioral training that we don't need to take a refillable bag with us when we go shopping, because conveniently there's something we can have for an instant and then discard without a concern. That's led to the immense success of plastics. And let's not forget, they bring societal benefits and the potential for environmental benefit. But at the moment, the benefits and the potential harms that we'll talk about are not in proper balance. We're seeing far more harm and long-lasting harm than we are benefits. And so we need to rebalance that. But the things that have made plastics such a success are the fact that they're lightweight, so you can use them in applications such as cars and airplanes and reduce carbon emissions. They're highly durable, so you can use them to protect and package goods that are otherwise perishable, extending the life of food and drink in the supermarkets, on our shelves at home. They're also inexpensive, which unfortunately creates a kind of paradox almost. We've got these highly durable materials, but the potential, because of their low cost, to use them in applications which are very short-lived. And finally, their incredible versatility. Everything from the monitor that I'm looking at you with, to the spectacles I'm wearing, to the pen on my desk, all plastic. So we've got versatility, low cost, durability, lightweight, incredible materials, but we need to rebalance to get the benefits to outweigh what currently are the immense environmental costs.
We were all kind of familiar, I guess, with the durability you mentioned and the difficulty of them degrading. And we all remember those images of sea animals with drink can holders in their necks and stuff like that. But something changed in 1993. Take us back, if you don't mind. I think you were studying barnacles, is that right? And you noticed something different. Can you describe that moment for us?
I'm a marine biologist by training, and in the 1990s, I was studying for my PhD. I was studying animals on rocky shores and how they interacted with each other to create an ecosystem, if you like, communities of interacting organisms. What I noticed in the experiments that I got set out was that I got rubbish arriving every day from the ocean, and I kept removing it. I needed to remove it to monitor the experiments, but it kept coming back. Most of it was plastic. And at that time, of course, nowadays we're familiar with the idea of voluntary beach cleans, but they weren't so common then. The Marine Conservation Society in the UK was starting to organise some. And so I worked with the other students to form a group cleaning up beaches for the Marine Conservation Society. And there's a few kind of twists of serendipity here. That was just, to me, a hobby almost, although I had been interested in plastics before that. I actually was looking back at my undergraduate dissertation in 1991, and I'd already recognized there was a problem here because I looked at plastic degradation and tested some plastics in the sea that were claiming to degrade. And what it struck me was the most abundant form of plastic debris, and that was the small pieces, the small fragments. Most of those cleaning up, the volunteers were looking for large, almost trophy items, but the small stuff was the most abundant. Nobody was even recording it. The question came to me, I wonder what the smallest bits of plastic are now in the environment. And so over the next decade almost, I gathered evidence about those really small pieces. And in 2004, we published the first scientific paper using the term microplastics to describe microscopic bits of plastic. And that paper was published in the journal Science, which is an incredibly influential journal. Nobody else was working on the topic at the time. I didn't receive any funding for this, but I could do it over a period of decades, working with students and undergraduate projects. I had the luxury of time to produce a really rounded paper that showed, going back in archived samples, that these microscopic plastics had accumulated over the last 40 years in the oceans, that they were now present in sediments and seawater around the UK. Also, we showed that a range of creatures with different means of feeding, filter feeders, organisms that usually shredded detritus at the top of the shore, could ingest this material. It didn't yet prove harm, but it proved the accumulation and the biological exposure. And from other work that we're also seeing emerging around plastics and the accumulation of chemicals, it was clear that there was a potential concern. And that paper in 2004 really launched the field of microplastics. There's now over 7,000 scientific publications on the topic of microplastics. And last year, we published a review summarizing what we'd learned over the last 20 years or so.
But just tell us a little bit about why plastics break down. I think you mentioned that the throwaway plastics are maybe not as durable. Is that the problem? Why do they break down so easily? What creates these fragments? And was this a design flaw, or was it just something that wasn't foreseen in the development of these new plastics?
Well, actually, the plastics are incredibly durable. That's why we rely on them in parts of cars and airplanes and even food packaging. But when they're in the environment, particularly exposed to sunlight, to mechanical action, wave action, for example, they can become ground up on beaches and they can eventually fragment into smaller and smaller pieces. So it's not that they're fragile, but over time, like everything, of course, they will break down into smaller and smaller pieces. There are enormous quantities of large items of plastic out there in the environment that will persist for many decades to come. But over time, those larger items are progressively breaking down into smaller and smaller pieces. And so I often say, I wish I had got a magic wand that I could stop the entry of plastic pollution to the environment tomorrow. But even if I did have that magic wand, we would still see an increase in microplastics over time, because of the legacy items that are out there in the environment progressively fragmenting into smaller and smaller pieces and ultimately microplastics. On top of that fragmentation of plastics into smaller pieces, we've also got a range of direct uses of small plastic particles in products. You're probably familiar with the microbeads in cosmetics, these small particles that were incorporated into cosmetics as an abrasive. Now, it was partly evidence from my group that led to the legislation in the UK to prohibit what's now described in policy as intentionally added source of microplastics. But microplastics are also incorporated still into other products, such as paints, for example. And on top of that, there's also the microplastics that are generated while a product is in use during wear of the product. And here you could think of tire wear particles generated as we go along the roads. Also, the release of fibers from textiles, including the clothes that we're wearing just now during this interview. So there's a range of sources of microplastics. One of those sources is the fragmentation over time of larger items. And that was largely what I was seeing on the seashore back in the 1990s.
Let's fast forward then. You mentioned your summary research paper recently. Do you mind summarizing what you have uncovered, discovered, or would summarize about your last 30 years of experience in this field?
Well, of course, initially, there was that first paper using the term. And I want to be really clear. There are other scientists before that, back in the 1970s, that had found small pieces of plastic in plankton samples and had documented them in the literature. They'd found them incidentally, rather than going to look for the smallest pieces. And there have been thousands since then, 7,000 publications or more now on the topic of microplastics. So I want to be absolutely clear. It's certainly not all attributable to me. I think we've done a lot at the University of Plymouth to contribute to that body of knowledge. And so as things moved on from that first paper in 2004, we were the first to show, for example, that these really small pieces had the potential not just to be eaten. And I think the key point here that was of relevance to policymakers was that as the plastic fragments get smaller and smaller, they become more biologically available. What I mean by that is more and more creatures can potentially eat them. It's going to take quite a large creature to eat a large plastic bag or a bottle cap or a large fragment. But as the pieces get smaller and smaller, they become available to a wider range of organisms. Going back to the early 2000s, what we showed was with the really small pieces had the potential not just to be ingested and cause a problem in the gut, a blockage, for example, but they could pass through from the digestive system into the circulatory system. And from there, they could move to other organs, tissues in the body. That was done with invertebrates. Now, it doesn't yet show harm, but it shows the potential pathways for harm in a different way to the purely physical interaction of entanglement that you talked about earlier on with aluminium can ring pulls, and also the larger items blocking the digestive tract, for example, of birds. So we showed this translocation from the gut to the circulatory system. We also showed the abundance of these microplastics was really worldwide. We looked on every continent, we looked at sand samples, and we found microplastic particles literally on every beach. What really surprised me is we also showed that it wasn't just locations close to population centers. Deep sea biologists contacted me saying, we think we found them 4,000 meters down. And indeed they had. And they'd found them in greater quantities than I was finding close to some of our major cities, which shows the potential because these are particles. They're not a contaminant that will dissolve in the water and will become more and more dispersed. They're particles that can be carried by water, and we also now know by wind, and can therefore reaccumulate in places far from their origin. And that was the case for the deep sea samples. But also I had Arctic scientists contacting me saying, we think we've got them in ice cores, and we established that as well. So we've shown ingestion. In lab studies, we showed wide-scale environmental distribution. We then went on to look at organisms that live in the environment. Working with a master's student, we showed that of a sample of 500 fish from the English Channel, there was microplastic contamination in a third of all the individuals that we looked at. Of course, the pressing question was always, okay, you've shown creatures are eating it. Is it harmful? And there's a range of potential types of harm that we explored. There was growing concern about the potential for chemical transfer. And that came from two sources, if you like. One, the chemicals that are used at the time of manufacture to make plastic products, some of which are put there with good reason, things like flame retardants, for example, but that in the wrong context had the potential to cause harm. In addition to those chemical additives, of which we now know, incidentally, that there are some 16,000 chemicals associated with plastic production, over 4,000 of which are known to be potentially harmful, but very few are regulated. And that's something we need to look into the future. But there was this issue of the chemical additives, some of which can be present at really very high concentrations. And that's why we see regulation of some of those chemicals in things like children's toys and products in hospitals, for example. But in addition to those additive chemicals, there was also concern that had largely come from a researcher called Shigi Takada in Japan, who'd shown that plastics would have an incredible affinity for chemicals that were already in the environment, particularly hydrophobic chemicals. And to give you an example of what I mean by that, if you think of washing up in a plastic washing up bowl after perhaps a spaghetti bolognese or a curry, the food dyes there are hydrophobic and they'll latch onto your plastic washing up bowl with great affinity, and you'll end up with a slightly stained bowl at the end of that washing up. The same process was happening with plastic debris. And in fact, in a matter of days, you could get concentration of chemicals from the ocean onto the surface of plastics, that the concentration increased by several orders of magnitude. And so here you've got the opposite now of what my marine pollution lecturer used to talk to the class about, as the solution to pollution is dilution. And what you've got with plastics is a vector that can reconcentrate some of those potentially harmful chemicals from the environment. And so what we showed was that when a creature ate plastics that we dosed up with chemicals at the same concentration as we find in the seawater near to me here in Plymouth, those chemicals were readily released to the creature. In fact, they could be released 20 or more times the rate because of the chemical conditions and the temperature in creatures. They would be released more readily than they might be released back into clean water. So we showed there was this mechanism, if you like, for accumulation of chemicals onto plastics, their magnification, and then their subsequent release. So we've now got two pathways for chemical harm, the additive chemicals and the chemicals accumulating for the environment. So we were starting to see emerging evidence of harm, and indeed others have demonstrated that accumulation by organisms and have demonstrated harm as a consequence of those exposures. In laboratory studies, and I'd emphasize some of those laboratory studies are at doses that are higher than we currently find in the environment. That doesn't undermine the value of those experiments, because of course it's really critical if we go to do a risk assessment to understand at what point these microplastic particles present particle toxicity or chemical toxicity. And that is now really clear. It's also clear that we don't know with absolute certainty the environmental concentration of microplastics, because many of them are too small for us to resolve, to pound. And so what we've got is a kind of almost a joining over time of the environmental concentrations, which are of course increasing because these particles are persistent, and the levels at which they're known to cause harm. And those things are getting closer, right? And so the modeling predictions that have been done on rates of accumulation of plastic in the environment suggest that within the next 80 to 100 years, if we carry on with business as usual, we'll see wide-scale evidence of ecological harm in the natural environment from these microscopic particles. We already know the large items of plastic are harmful. We already know they present harm to wildlife, present harm to economies, and can present harm to human health. The key additional bit is the evidence around the microplastics. We know that they're harmful in lab settings at concentrations that are sometimes higher than in the environment. Of course, if we carry on contaminating the environment at the current rate, the modeling predictions therefore show that at the moment, that harm in the environment from microplastics alone is probably quite isolated, but we will reach a stage of widespread contamination if we don't change our ways. So to me, the warning signals are there that we need, with some urgency, to start to use plastics more responsibly.
How are plastics affecting food production?
It's a really good question. And of course, that presents one of the direct pathways, of course, to us as humans. And we know that one of the major uses of plastic is in packaging, including food packaging. And there's clear evidence that plastic particles can leave that food packaging and the potential then to consume it with the food. We've also shown that there's plastic present in commercially important species, such as some of the fish that we looked at. But interestingly there, we did a follow-on experiment showing that the quantity of plastic, let's imagine in a fish supper, that was coming back from the ocean was far less than the quantity of plastic in the air around you in the kitchen while you're preparing the meal. So that was one of the major sources for human exposure, was actually plastic in the home and in the environment. The dust that you're cleaning up at home, a lot of it is, of course, plastic. And then, you've got the uses in packaging. And recently, we've also shown that even the vegetarians amongst us are not immune. We showed that nanoplastics are potentially able to migrate into the edible parts of vegetables, such as radishes. So it's absolutely there. And there have been studies demonstrating the accumulation in beer in a wide range of different types of food. And so I now summarize the evidence in terms of human exposure as microplastics are literally in the food we eat, the water we drink, and the air we breathe.
So given what we know, has the scale of plastic production changed recently? And I know you've been involved in some kind of global negotiations that maybe didn't go quite to plan. Do you mind just summarizing kind of the global take on plastic production and what is currently the appetite for change?
It's really clear that plastic production is increasing almost exponentially. We've gone from 5 million tons of plastic produced globally in the 1950s to over 400 million tons of plastic today every year, 40% of which is used in packaging, single-use products. And the predictions are that the quantity of plastic produced is going to triple over the next few decades. And of course, some of those in the industry, because it's largely fossil oil and gas, that's the carbon source, are rightly concerned about the pressure to reduce the use of carbon as a fossil fuel. And they're looking to things like plastics as an alternative market. And so the predictions are that unchecked, plastic production will increase considerably above the 400 million tons of plastic that we have today. So there's real concern about the levels of production and whether or not how we manage that. So going back about 3 years now, there was a resolution taken to the United Nations, UNEA Resolution 514. And in that, what we saw was over 170 countries agreeing that there was a problem with plastic pollution currently and that we needed to develop a treaty to address that. And that was a real shift for me in the decades that I've been working on this topic. If I were to go back 20 years, there was not agreement in the industry that was even a problem. Policymakers had immense disagreements about what were the levels of concern or harm, or even whether there was a problem at all. I remember one policymaker saying to me that they weren't going to do anything in their country until the science proved that it was harmful to humans. So we now got this immense shift that we've got 170 nations. There might be disagreements still on absolute quantities or numbers of turtles affected or exposure to humans, but they agree there's a problem. And that's a massive shift in terms of where we are with the science. And it takes me and my team at the University of Plymouth from the priority being to define the problem to the priority being to identify and test potential solutions. So we got this massive shift. The problem, of course, comes despite you've got that 170 plus countries agreed that there's a problem they need to work on. Getting them to agree on a solution is much more challenging. And that's where the current negotiations have fallen down. We've had 6 rounds of discussion. We failed to reach an agreement. I mean, any negotiation like this, of course, there's going to be potential winners and losers. And that's the concern. Plastic's a big business. And so there's concern, there's economic concern, some of which is at the level of the UN member states. And that's why actually financing is going to be really important to make sure that the cost of solving the problem doesn't fall disproportionately on some nations. And unfortunately, unless we have that financing, the predictions are that the cost of addressing this problem could fall disproportionately on some of the poorest countries, which is where, unfortunately, at the minute, the environmental and health burden of plastic pollution is mainly falling. It's frustrating to me also that there's no formalized mechanism to bring independent scientific evidence to the negotiators in the treaty. And by independent, evidence that's free of conflicts of interest. At the last round of negotiations, some journalists did a calculation that there were more industry lobbyists there at the meeting than there were actual negotiators. So there were lobbyists, there were actors who've got skin in the game, potentially delivering misinformation. So the pathway, the access to science is really key as part of this, but there's no formalized mechanism to do that. As a scientist, I can attend these negotiations if I can persuade my university to give me the time to go, and if I can find the finance to get me the travel and accommodation there, then I'm allowed to participate as an observer. And as an observer, I'm able to make fairly modest interventions about the evidence base. So there's a clear problem around getting the evidence to policy. And so recognizing that 3 years ago now, a handful of scientists around the world, I was one of them as a founder member, we formed this organization called the Scientists Coalition for an Effective Plastic Treaty. Where are we with the negotiations at the moment? They stalled in the summer in Geneva that we're hoping to get an agreement, as indeed it had been before in Busan, which was the discussion before. And that's the problem. They're all agreed that there's an issue. They can't quite agree on the solution because it's going to affect them differently. Where we are at the minute, I'd say, is we've got a very substantial number of countries that have a high ambition. More than 120 or so that are aligned with what might be needed for a successful plastic treaty. We've got a much smaller group that are sometimes called the like-minded group that have got lower ambition, and then largely countries that have more of a financial stake in the production and sale of fossil oil and gas. So it's understandable, but they have a lower ambition. But then you've got a very substantial number that remain in the middle that are undecided. And that's a place where I believe the science is really important, because in some cases, those countries that are undecided are potentially undecided because of this lack of scientific evidence. Access to science will actually help us achieve the common ground that's needed to reach an agreement in the treaty. But as I say, the only process that's currently delivering it is our voluntary network of 400 scientists in the Scientists Coalition for an Effective Plastic Treaty.
So, given the best evidence we have is maybe in marine animal, it's easier to research. What is the best evidence that it has an impact on life expectancy in animals? We know that it accumulates, but is it shortening life? Is it causing disease? What do we know so far?
There's now been a wide range of studies looking at the effects of harm. And of course, you need to recognize that the microplastics, they're not one thing. We've got multiple polymers of multiple sizes. So there's lots of different permutations of the contaminant, of the pollutant. And some of those will be more likely to present harm than others. We're seeing effects that compromise the ability of organisms to feed, to put on weight in the normal way, to grow and reproduce in the normal way. We're seeing evidence of effects on behavior. So we're seeing a wide range of effects. Now, some of those laboratory studies have been criticized because they've used relatively high doses of plastic compared to those that we currently find in the environment. But of course, if we carry on contaminating the environment at the current rate, those two things are going to merge. And increasingly, we're starting to see evidence from laboratory studies at concentrations that are close to those we see in the environment. And so the predictions is that we're going to see this wide scale ecological harm in the environment in the next few decades if we don't take action to address. And that's harm from the microplastics on their own. In my view, more than enough evidence of harm for us to take action. And there we've also got, of course, 170 countries agreed that there's harm from plastic pollution.
I know this is probably a difficult question. Without the absolute evidence in human health, perhaps we're living in this era like tobacco smoking where it just is going to take a long time to accumulate enough evidence to convince everyone. But given everything, how concerned are you about the risks? And I guess there's these rises in disease that we see, and we're always confused as to what's causing it. Cardiometabolic health, declining fertility, rising cancer rates in young people. A second question, I guess, would be, is there any suspicion in the community that some of those are potentially caused by microplastic ingestion?
I am certainly concerned about the risk of exposure to humans. We've got a substantial body of evidence from laboratory experiments with animals demonstrating harm. We know that humans are exposed through the water they drink, the air they breathe, and the food that we eat. We're just another animal. Why would we imagine that we're immune from it? There are major scientific conferences now devoted to aspects of human health related to micro and nanoplastics, including on the liver and on reproductive health, particularly associated with some of the chemicals that are used in plastic production and plastic use. So we're seeing wide-scale interest in the medical community, the medical researchers. There have been some papers demonstrating what I would call associational effects, because, of course, I can't do a laboratory experiment with humans, but associational evidence of increased risk of cardiovascular disease, for example, and concentration of microplastics. And let's not forget that some of those chemicals that are used in plastic production, the evidence of harm to human health is already immense, and those chemicals will also be associated with microplastics. So the harm associated with some of the plasticizers that are used to make plastic bendy. There was a paper from a scientist in the last couple of years showing that the potential global human health costs associated with those plasticizers alone could be of a similar order of magnitude. The loss of life and the cost in supplying healthcare could be of a similar order of magnitude to the entire annual value of the plastic market. So we often say that plastics are inexpensive. They are to produce, but there are immense externalized costs to the environment and to human health that really, for me, absolutely clearly say we need to change our ways. You use the example of tobacco. I would argue we'd got categorical evidence that tobacco was harmful to humans a long time before we took the policy measures. And that was partially coming because of denial and misinformation from actors that had skin in the game that stood to lose out very substantially financially. But there's a difference here to tobacco. As far as I know, there's not really a safe way to use it. But that's not the same with plastics. What we need to do is to keep the potential benefits to society and the environment that plastics bring without the current harm. We're talking about negotiations of a treaty to address plastic pollution. That's not a treaty to end plastic production. It's a treaty to end plastic pollution. And to me, there are immense commercial opportunities here. It's not the end for the plastics industry, but it has to be a start of more responsible production that at least conceives of what's going to happen to a plastic product at the end of its life. And yet, when I talk to product designers, even with single-use products that we use for a minute or so and discard, they say thinking about end of life for those products has simply not been on the drawing board. It's not been in their brief. They're asked to design something that functions and is attractive. And that's why we've got this enormous problem. So to me, we've got the clear evidence that we need to change our ways.
So presuming the greatest benefits will come from policy, but until that happens, if there are a concerned individual like myself, concerned for myself and my children, what are some of the things that we can do to reduce our exposure? Let's start with, what are the lifestyle choices that would probably have the greatest impact on exposure risk?
So if you're talking about exposure to micro and nanoplastics, that's really going to be hard to solve as an individual, because of course they're all around us. But that doesn't mean you can't take steps to reduce plastic pollution, particularly in the longer term. And this is one of the frustrations when we talk about solutions, that by and large, the solutions that are required, we've known for over 50 years. It is about the 3Rs. It is about reduce, design for reuse, and design for circularity. And all of that is going to take another R, which is redesign. So the challenge for the moment, and education is going to be really important, but the challenge is, how do we educate the consumer to interact with a system that's currently broken, where we've got products being designed with no conception of how they're going to be disposed of. So we really need policy and industry to step up to the plate to make sure that we're designing plastics in a more responsible way. But for sure, there are things that we can all do as an individual. And let's start with the reduce. We can all reduce our plastic footprint. And taking a refillable bag with us when we go shopping is a pretty obvious one. It might seem trivial compared to all the plastic packaging on the things that you then put in the bag, but collectively there are billions of plastic bags used worldwide, literally every day. We can make a big impact through personal choices. Taking a refillable container with you when you go to get a coffee is going to reduce the amount of throwaway plastic cups and lids that we use. Again, it's piecemeal, but you think about the number of those that are sold, used, purchased every day. It's immense, and it does all mount up. But there's no point having refillable containers if they sit in the cupboard at home. The last one of these I had lasted for over a decade. Unfortunately, I left it in one of the negotiations when I was getting tired, and I've had to buy a new one. You need to do it, but then you got to walk the walk. So there's using reuse formats will definitely cut down on the amount of plastic that you use. In terms of the things where it's almost unavoidable to end up with something in plastic packaging, and I also think we're going to need to retain plastic packaging. The solution isn't about an aisle that's completely devoid of plastics. It's about making sure that the producers and the major brand owners have done their homework in terms of design and what is on sale, to take that responsibility, to take that burden away from the consumer. I mean, in the UK, we've got pretty good curbside collection of end-of-life plastic. Now, what is collected and potentially recycled, because there are challenges there, but what is collected by different local authorities varies immensely. So I would say check with your local authority. What types of plastic packaging are they happy to accept on the basis that they are hoping it can be recycled? Because yogurt pots can be recycled in one county and not another. So try and help the local authority by delivering them the plastics that they claim can be recycled. And there are challenges there for the local authority and the recyclers, because, as I say, we're designing very little at the minute with end-of-life circularity in mind. The last thing, and it's another R, and it really came home to me actually when I was talking to a local community group last week before I went to give the talk. I asked if I could have a glass of water, and there was a bar there. There were lots of people having drinks in glasses and coffee cups and things that were reusable. But the glass of tap water, because of course I'd asked for tap water because in the UK we're fortunate enough to have perfectly good drinking water coming from the tap. We don't need to move tons and tons of water around in plastic or glass bottles just for our convenience. We need to ditch that, give money to Water Aid instead. So I asked for tap water. The only way they were prepared to give me tap water, and this is bizarre, is in a throwaway single-use cup. So I immediately had to pour it into a glass container. But the thing we should have done was refuse. So refuse is a really powerful thing that you can do to raise awareness of the issue, whether that's restaurants, bars, shops. There are things that if we can do without it, we can refuse. So I think as actions we can take, but we also need to try to communicate why we're taking that action, because the market is sensitive to even small resistance from the consumer. That's the last thing that the producers want. Show your dissatisfaction and disappointment. And I'll give you an example there of, we took a tour around a really advanced recycling plant near to London. It was one of the most advanced facilities we got. At the end of the line, there was a conveyor belt and there was a human being standing there. And I asked the question, what's that person doing? And they said there had to be somebody there 7 days a week, 24 hours a day, 365 days a year. And the role, the job description, if you like, for that role was purely to intercept a type of sports drink that was of a potentially valuable polymer, but the manufacturer had chosen to camouflage that potentially valuable polymer in an orange-colored sleeve of a different polymer. That meant that our best recycling infrastructure was now unable to detect the valuable polymer, and that a human being had to stand there to intercept these particular bottles. Now, that additional colored plastic sleeve wrapped around the sports drink was doing nothing for food security. It was doing nothing to help to protect the drink, nothing to extend its life on the shelves. It was purely there, in my view, for brand differentiation, to make that product stand out on the shelf and say, buy me. So here was a clear example of a lack of thought at the design stage, taking a polymer, PET, a polymer that we've known for decades is highly recyclable, and in a country where we've got advanced sorting and recycling, camouflaging it from the best recycling infrastructure that we'd got. So there's a clear need for design to step up to the table and design as products that are as compatible as possible with circularity. We cannot carry on squandering the world's resources in the way that we're currently doing.
So thinking purely on the ingestion of micro and nanoparticles for my own personal health, there's so much on social media now. I don't know if there's justification for all of this or if there's absolute merits in making these decisions, but have you made any lifestyle changes yourself based on what you know to reduce your own personal ingestion of these plastics?
I just want to dispel this idea that there's somehow no connection between the amount of plastic that I use and the quantities of micro and nanoplastics in the air, in the water, in the environment. The things are linked. If we all reduced unnecessary plastic consumption, and if smarter products were designed, that would reduce the amount of microplastic exposure. Let's not forget, when we started discussing this, the majority of microplastics, yes, there are a variety of sources, but the majority of them are coming from the fragmentation of larger items. So there are definitely things that we can do there to reduce their exposure collectively for all of us. Now, in terms of lifestyle choices, I try to use as little plastic as possible, but it's difficult to eliminate it from our lives because of the way that goods are shipped and supplied, but I try to minimize that. Beyond that, we've certainly done experiments on tea bags and shown that some of these have plastic in them. If there's anything I can possibly reduce, that I will. But I think we're kidding ourselves a little bit if we think that all of this can just be solved by lifestyle choices of not taking X, Y, and Z. There are things that we can reduce that we don't need, this single-use coffee cup. But in terms of the dust that's in the air, the particles in our water, the particles in the food, it's very hard for you as a consumer to minimize their exposure. We need to solve the problem further back upstream, as it were. So one of the types of microplastic that I'm particularly concerned about is the particles that come from tire wear. And until a few years ago, we hadn't really realized the scale of those. And it shouldn't come as any surprise. You drive a car along, after a year or so, you have to change the car tires, and you look at the difference in the tread. If I'd got a bag of all the dust you generated by the time you need to change 4 car tires, it would be a bag of about 4 or 5 kilos of dust, literally a rucksack full that's gone directly into the environment. Some of it washed off of roads into watercourses, other quantities in the air and blowing around. Those tires, if you look at the chemical profile of them, have got a wide range of chemicals of considerable concern. And I think it is clear that there's dust and that's going to result in human exposure. But of course, these aren't products that are intended for food contact. So the amount to which there's been regulation or thoughts about those chemicals used in tires is very different to, let's say, the chemicals in a plastic children's toy. So I think we need to look at that because there's clear evidence if you're living in a big city of the potential for exposure or living along the side of a highway. And we've seen the same thing with what was called the exhaust emissions. They're taking the lead out of petrol. Now the major focus is, of course, on those non-exhaust emissions, including the tire wear particles. And there's particular concern that as we try to solve the environmental problem related to climate and we move to electric vehicles, of course, they've got more torque and they're also heavier and will generate more particles, more tire particles. That's not a reason to move away from electric vehicles, but it's telling them we also need to look at the tires. And the interesting thing there is when we do look at the tires, if I look at the chemical profile of the 5 main brands of tire that are sold worldwide, there are immense differences in the type of chemical composition. Some have got a really high concentration of chemical A, the next brand hardly has any. So what it's telling me is there's highly likely to be better formulations, that we're not eliminating all the tire wear particles, but we're making any emissions that there are as safe as possible. On top of that, I would say that the rate of wear of tires, there's evidence in the industry that a long-lasting tire will potentially last twice as long. That means it's wearing out at half the rate. So if we could make the tires last longer and any emissions that did arise safer, that would be a big step forward. And it's exactly the same if I think about the textiles that we're wearing. Even a budget textiles is up to a 70% difference in the rate of shedding when you launder them. And that could be solved by better design, even adopting current formats that are in the shops. We do see a move to try to put the burden on the consumer. The French are now mandating filters in washing machines, and there's discussion in the UK about doing the same. And I'm not against the idea of a filter, but the lab tests we've done on 5 different devices, either in drum or a filter, showed that 3 of them had no significant benefit at all. The other 2 caught the fibers, but then there's the question of how does the consumer deal with it? Do they end up washing out the filter under the tap and returning them back into the water system? We've already got clear evidence that a bit smarter thinking at the design stage could do a heck of a lot. And on top of that, I'd add that we've also shown that half of all the emissions actually come while you're walking around wearing the clothes from abrasion rather than while you're washing them. So anything we do at the washing machine stage or the wastewater treatment phase is never going to capture those emissions from clothing while we're wearing them. But smarter design, we've had clearer evidence for well over a decade that we can produce clothes that shed fibers 70% lower rate. So why don't we do that? So there are definitely things where we can make a difference. But ultimately, if I were to look to the supermarket of the future, to the products of the future, because we already know that industry could design tires that would probably wear at half the rate, that we could produce textiles that would shed 70% less fibers when we wash them, that we could design plastic packaging that was far more compatible with circularity and recyclability than we currently do. What I want if I picture the supermarket of the future is the consumer doesn't have to have all that burden on them, that the homework has been properly done by the brand owners and the large retailers so that you can buy something wrapped in plastic if you need to, and of course reduce it if you don't. But if it's essential that it comes in plastic, that the homework has been done, and if you put it in the recycling bin, you can put it there with confidence. I'd far rather you were agonizing in the supermarket of the future over, let's say, the food miles on strawberries that you want to buy in the middle of the winter than having to try and work out whether the local authority can or cannot recycle the piece of plastic that's been badly designed in the first place. So there are lifestyle choices, definitely. Reduce, reuse, recycle. Beyond that, in my view, sort out the maintenance on your car, think about washing your clothes a bit less often. But a lot of this sits with better design. And we keep pointing back to that. And I also worry that we're never going to be able to rely on every one of the billions of people on the planet to behave in this more responsible way. The small number of individuals, in my view, that need to be more responsible is those at the design stage. They need to design us smarter stuff, cognizant of the fact that a lot of it will wear while we're using it and will generate micro and nano particles, and solve it from the design stage. But there are those things that we can do about reducing our footprint that collectively will make a very substantial difference. Because let's not forget that those large plastic items of today are the microplastics of tomorrow.
So thank you very much. We're coming close to the end. I wanted to just look, maybe, I don't know if we can look positively to the future, but is there anything that you're excited about? What's coming? Are we any closer to finding an alternative product that has the same good qualities, but maybe not so much of the downsides? Or anything else in the sphere and the plastics world that you're excited about that's coming?
You used earlier on, you said was this like the problem around tobacco and the slowness to take action. And it's not, because this isn't a treaty to stop us all using plastic. It's not, to me, about having all of the aisles in the supermarket free of plastics. It's about learning to use them more responsibly. So I'm very much glass half full. There are immense business opportunities for those that are the first adopters of safer and more sustainable products. The risk to business, I would say, is putting your hand in the sand and carrying on with business as usual, because we've got 170 countries now that are agreed it's a problem and they want to work towards a treaty to address that. But it's not a treaty to end our use, and I think there are immense opportunities. What we need, therefore, in my view, is clear criteria to guide us. And you said alternative products. The challenge here is not different wonder material. We need to keep those lightweight, durable, inexpensive, versatile features, but use them more responsibly. Simply switching a different material without the change in the way we design the products isn't on its own going to solve things. The way we design the products and handle the associated waste is going to be key. So therefore, we need, as part of this treaty process, and I think it needs to be facilitated by scientists who are independent of conflict of interest. We need to design criteria for safety so that we can recognize a safe plastic product when we see one. And that's particularly pointing towards the some 16,000 chemicals associated with plastic production, 4,000 of which we know are potentially harmful. So we need criteria around safety. And there are already some, but they need to be immensely expanded. We also need criteria around sustainability, particularly around large production volumes of items that are single use. And we've seen, for example, the banning of microbeads in cosmetics, those small plastic particles, hundreds of thousands of which were in cosmetic products. A few years ago in the UK, legislation now to prohibit them. I haven't heard a single consumer complain that they can no longer scrub themselves in millions of small bits of plastic every morning. They clearly weren't necessary. The government took the right steps to prohibit them. So we need to work out, in essence, what's safe, what's sustainable, but also what's essential. Those microbeads in cosmetics were not essential. And in my view, we're making a lot of plastic products that don't bring clear, essential benefit to society and the environment. So we need a set of criteria that policy can use and can apply that will help us work out which are the plastics that bring essential benefit to society and to the environment. And that's a little bit analogous to the essential use protocol that was very successful in reducing the ozone depleting gases in aerosols, for example. And so we need to do that with plastic products. And for those products that bring essential benefit, we then need criteria to make sure that those products are as safe and sustainable as possible. And I think all of that is achievable. On top of all of that, we also then need the testing so that we know that we've reached a certain point of certification in terms of safety and sustainability. And we need transparency and labeling so that you can recognize a safer and more sustainable plastic product at an international border. If you're a big supermarket retailer, you can recognize these things and you can therefore reward the innovation by those first adopters in the industry that have been producing those products. At the moment, I hear from company A that they're really keen to make plastics more sustainable, more responsible, but they worry that company B, without a level playing field of legislation, will simply undercut them by continuing with business as usual. I think that the message is there that we need to change, that business as usual is a real risk, that there are opportunities, but I think we're going to need policy measures to make sure that those first adopters of safer and more sustainable plastics are supported, and we need criteria to do that. And then we need appropriate testing and labeling so that those products can be clearly recognized, including by the consumer. But ultimately, I don't think the consumer ought to be agonizing over little labels about the plastic on the products in the shop. We ought to have done that homework earlier on. I would far rather the consumer were agonizing over something like the food miles on the strawberries they were buying in the middle of winter, because that's not something we can fix by better design.
Just on that point, you've mentioned there's 4,000 odd chemicals that are potentially harmful, yet the one that probably most people know about is BPA. And does that rightfully have its own place as being something that we need to be conscious of or not? And should we still avoid it, or are there just too many other chemicals that need to be considered fairly equally?
There's clear evidence of harm from phthalate plasticizers, of which BPA is one. And we've known that for some time now. I think the approach that we need to take is what I would call a groupings approach. It's illogical to try to do a risk assessment on every chemical out there and then to ban plasticizer A, and all you see is the industry response being to design B and C, a slightly different formulation, which bypasses the legislation. What we need to do is look at categories of chemical by grouping, and we need to basically say, okay, if some members of that group of chemicals have been shown to be potentially harmful, we need to take action on all of the chemicals in that group. It's not about simply making a different version of something that's equally harmful. And that would be where I would place the emphasis, and I would use clearly developed safety criteria to try to move us away from those chemicals. And in some cases, a little bit like the essential use protocol that I've talked about that helped to rid us of some of the ozone depleting gases, there will be exceptions where currently there's a clear benefit of using a particular chemical and we don't have an alternative. And there what we need to bring is time-bound restrictions. So it's really clear to the industry that this is something we've identified as a problem. It's a risk. We need to change our ways. There's a real market opportunity for innovation to design something that's smarter. So we need clear signals to industry, and we need to make sure we've got a level playing field. And some of that is the transparency and the labeling coupled to the appropriate standards to foster the innovation in smarter, more sustainable plastics and discourage and disincentivize the bad practice that we've seen of not even thinking at the design stage about some of these things.
And finally, we always leave our speaker one last chance just to leave the listeners with a final few take-home points. If you were wanting to leave us with anything specifically, what would be your key take-home message?
If you're a policymaker, have the highest ambition that you can to help us to end plastic pollution, because it's definitely something that we can solve. As a co-coordinator of the Scientists Coalition for an Effective Plastic Treaty, we've got dozens of policy briefs there on some of the actions that we need to take, and we're more than happy to have policy discussions as independent scientists. If you're based in the industry, I'd say there's a real business opportunity here for those first adopters of safer and more sustainable plastics. But again, we need that to be facilitated by standards and labeling and testing to help to reinforce that innovation. And if you're a consumer, it's about reducing use, it's about reusing, it's about buying things that are, to the best of our knowledge, recyclable. And if you see bad practice, use the R of refuse and say, no, I'm not going to buy from your particular fast food, takeaway, whatever it is, if the only way I can take that away is in a disposable container that, has a really low potential to be recycled. Think about going somewhere else.
Professor Thompson, thank you so much for joining me today.
It's been my pleasure. Thank you.
So huge thanks again to Professor Richard Thompson for the interview. I think my key take-home messages are, number one, plastics fragment in the environment into microscopic particles. These get eaten by animals, including us, passing through the gut wall and into the bloodstream, and they can be circulated from there to all of the organs in the body. Number two, it's not just the particles. Over 16,000 chemicals are associated with plastic production, and more than 4,000 are potentially harmful, and very few are regulated. Number three, microplastics are in the food you eat, the water you drink, and the air you breathe. The air in your kitchen while you cook contains more plastic than the fish on your plate. You cannot avoid exposure entirely, but you can reduce it. Number four, it is very difficult to research the impact on humans, but the evidence linking microplastics to human harm is growing fast, including increased risks for cardiovascular disease, liver damage, and reproductive health problems. And finally, number 5, Professor Thompson's key message is to reduce plastic use in general, reuse items and avoid throwing away if possible, recycle what you can, and refuse unnecessary plastic use. Some other specifics include drink tap water instead of bottled, wash clothes less often, and drive smoothly to avoid excessive wear of tyres. Don't forget you can find lots more content at stressfreelongevity.com. Until next time, take care.